Hello students, let us discuss about the architecture of 8085 microprocessor. 8085 microprocessor is 8-bit microprocessor because it has word length of 8 bit. It is general purpose microprocessor since we can instruct this microprocessor to perform various types of tasks. It is capable of addressing 64 kilobyte of memory. This device has 40 pins. It requires plus 5-volt power supply and it can operate with 3 MHz single phase clock. 8085 microprocessor is upward compatible with that of 8080A, meaning that the 8085 instruction set includes all 8080A instruction set plus some additional instructions. This figure is logic pinout diagram of 8085 microprocessor. This device has 40 pins. Pin number 1 and 2 are allocated for frequency generator. Pin number 3 is reset out. Pin number 4 is SOD. Pin number 5 SID. Pin number 6 trap. Pin number 7 RST 7.5. Pin number 8 RST 6.5. Pin number 9 RST 5.5. Pin number 10 INTR. Pin number 11 INTA complement and pin number 12 to pin number 19 are for multiplexed address data bus. VSS is pin number 20, that is for ground. Pin number 21 to 28 are address bus from A8 to A15. Then pin number 29 is S0. Pin number 30 is ALE. Pin number 31 is write complement. Pin number 32 is read complement. Pin number 33 S1. Pin number 34 input output oblique memory complement pin. Pin number 35 ready. Pin number 36 reset in complement. Pin number 37 is clock out. Pin number 38 is HLDA. Pin number 39 is HOLD and pin number 40 is VCC, that is power supply of plus 5-volt. To understand function of these pins, let us classify these pins into 6 group. First, that is address bus. Second one, that is data bus. Third classification is control and status signal. Fourth classification is power supply and frequency generator signals. Fifth classification is externally initiated signals and sixth one is serial input output ports. Let us discuss about first classification, that is address bus. Here you can see address bus from A8 to A15. This is considered as a high order address bus and from AD0 to AD7 is considered as a low order address bus, but it is multiplexed address data bus. Third classification is control and status signals. This group of signals include two control signals, read complement and write complement. Three status signals, input output oblique memory complement S1 and S0 to identify the nature of the operation, and one special signal which is ALE, which is used to indicate the beginning of the operation. Let us understand this signals function of this signal in detail. ALE, that is address latch enable. This is positive going pulse. It is generated every time when 808Y begins an operation, that is machine cycle. It indicates that the bits AD7 to AD0 are address bits. This signal is used primarily to latch low order address from multiplexed bus, address data bus, and generate separate set of 8 address lines, that is A7 to A0. Read complement, which is read. This is read control signal, which is basically active low signal. This signal indicates that the selected input, output or memory device is to be read and data are available on data bus. Write complement, that is write. This is write control signal, which is also active low. This signal indicates that the data on the data bus are to be written into selected memory or input output location. Next is input output oblique memory complement. This is status signal used to differentiate between input output and memory operations. When it is high, it indicates an operation, input output operation, and when it is low, it indicates the operation is memory related. This signal combined with read complement and write complement to generate input output and memory control signal. Then next is S1 and S0. These are status signal similar to input output oblique memory complement. They can identify various operations, but they are rarely used in a small systems. Fourth category is power supply and clock frequency. VCC is for plus 5 volt power supply. VSS for ground reference. X1 and X2. A crystal RC or LC network is connected to these two pins. The frequency is internally divided by 2. Therefore, to operate a system at 3 MHz, the crystal should have a frequency of 6 MHz. Clock out, that is clock output. This signal can be used as a system clock for other devices. In addition to interrupts, 3 pins, that is reset, HOLD and ready, escape externally initiated signals as input. To respond to hold, that is HOLD request, the 8085 has one signal called HLDA, that is hold acknowledge. Then pin number 36, that is reset in complement. When the signal on this pin goes low, the program counter is set to 0. The buses are tri-stated and MPU, that is microprocessor, is reset. Then reset out. This signal indicates that the microprocessor is being reset. The signal can be used to reset other devices. Sixth classification is serial input output ports. The 8085 has two signals to implement serial transmission, that is SID and SOD. SID means serial input data, SOD means serial output data. In serial transmission, data bits are sent over single line, one bit at a time. Such transmission is called as a serial transmission.